Good afternoon, sir. Good afternoon, classmates. I am tasked to report the topic Incorporating Earth Science into Other Science Classes. By the way, I am Shalajoy P. Osico and I am your presenter for this afternoon. Here are the objectives of this report or topic. First, we will explore some different approaches to integrate earth science concepts into biology, chemistry, and physics courses by finding the interconnections between the sciences using the Next Generation Science Standards or the NGSS. We already discussed this from the previous reporter. And we will identify ways to reference the role of earth sciences in the other sciences during lectures, activities, and laboratory assignments, and develop relevant problems for students to solve that weave the sciences together. The workshop is called Earth Educators Rendezvous, and the participants are Cheryl Manning from a science teacher, National Earth Science Evergreen High School, and Teachers Association Evergreen, Colorado. And the focus of this workshop is using current issues, media stories, and problems affecting participant communities or participating communities. And they will work in collaborative teams. Participants also will develop interviewing problem statements, setting the stage for high school students to research and design solutions using an integrated science approach. And by the end of this workshop, the participants will have created a lesson or unit of study that engages students through problem-based learning and the list resources that can be used in solving the problem. Here are the goals of the program. Using the Next Generation Science Standards or the NGSS, the participants will identify the earth science ideas in the disciplinary core ideas or DCI, cross-cutting concepts, and science and engineering practices that can be woven into high school biology, chemistry, and physics courses. These are the other science courses that earth science can be integrated. Second, participants will collaborate to create problem-based learning opportunities for students to investigate and develop lessons and units of study. And participants here are encouraged to bring lessons that they would like to work on. During the workshop, the participants are tasked to list the issues of earth science courses in high school. First on the list is earth science is taught in middle school. In an ideal world, earth science should be a senior level course required for all students, however, this is not the ideal world. Second, in the 4 years of high school, most students take courses in biology, chemistry, and physics because this sequence leaves room for electives, AP Science courses, and etc. And these are also required by most colleges. Third, understanding the complexities of earth science requires a solid understanding of chemistry and physics. And the last one, most science teachers have degrees in biology or the physical sciences. Despite the issues of earth science courses in high school, there are many opportunities to incorporate earth science concepts into other high school courses. And what are we doing today and why? First, modeling an instructional style that you will be able to use when working with pre-service and in-service teachers. Second, exploring the links between earth science and traditional biology, chemistry, and physics courses. Third, creating resources that could be used in high school classes and could be archived on the Earth Educators Rendezvous site and beyond. Here, they will use the NGSS, the performance expectations, the three-dimensional learning, the disciplinary core ideas, cross-cutting concepts, science and engineering practices, and high school earth and space science concepts like space science, space systems, history of the earth, earth systems, weather and climate, and human sustainability. Here are the list of concepts in life science, earth and space science, and physical science. After listing the other sciences concepts, the participants will proceed to their activity called work groups the other sciences, and the question is, in which of the following might earth science fit? In biology or life sciences, these are the topics: structure and function, inheritance and variation of traits, matter and energy in organisms and ecosystems, interdependent relationships in ecosystems, and natural selection and evolution. And in physical sciences, it is divided into two: chemistry and physics. In chemistry, structure and properties of matter, chemical reactions, and energy. And in physics, forces and interaction, energy, waves, and EM radiation or electromagnetic radiation. Getting started. First, they will start by acknowledging what they know best, the earth and space sciences. This is already a part of your thinking, so we will rely on that background knowledge. Second is get into groups, the biology, chemistry, or physics. Third is in their groups or in your groups, find out what is being taught in the other science high school courses by examining the performance expectations and disciplinary core ideas in the NGSS for physical science. And they will focus on either chemistry or physics or life science. Next is check out some of the teaching resources on the Teach on Earth collection using this link. After that, they are tasked to make connections. First, using the NGSS, examine the DCIs for biology, chemistry, or physics. Second, start identifying those disciplinary core ideas in your subject area that could be demonstrated using Earth and space science phenomenon. Next is use the Google Docs created for your group to organize your thinking: biology, chemistry, and physics. Next is examine the disciplinary core ideas in the Earth science and find the DCI that best connects to your listed DCIs. And if you don't find a match, you may need to reframe it or let it go. Last is brainstorm some questions that might be generated by teaching this Earth and space science content in the other subject area. After making connections, they are tasked to create learning opportunities, and they will work together to first choose one of the questions above that would challenge students' thinking in both your subject area and the Earth and space sciences. Second, use that question as a guide to create a lesson, project, or unit of study that teaches both the subject area and the Earth and space science concept. Third, if you have time, identify the NGSS cross-cutting concepts and science on Earth, science engineering practices your lesson incorporates. Next, or last one, sharing your lessons and feedback on what makes these good lessons. What were the challenges of connecting the conceptual understanding, and etc. For us to better understand the workshop, I will show you the actual activities they created. I am fortunate because the owner or one of the participants emailed me their actual activities. First is incorporating earth science into biology. Here, in the first column, they list 5 disciplinary core ideas in biology that can be demonstrated using earth and space science examples or content. Like for example, cycles of matter and energy transfer in ecosystems. Second column, list the earth and space science disciplinary core ideas that connect to the biology DCI. But if you don't really see a match for one of your connections, you may need to leave it out or reframe it. Here, feedbacks between biosphere and other Earth systems. And in the last column, brainstorm some questions that might be generated by teaching this Earth and space science content in biology. And here are the questions they generated. First, how is melting ice changing climate, and what is the impact on polar ecosystems? Next, how do human influences on the carbon cycle impact climate? and many other questions. And let's proceed to incorporating earth science into chemistry. Same lang gihapon ng first column, second, and third column. Here, chemical reactions, chemical processes, the rates, and whether or not energy is stored or released can be understood in terms of the collisions of molecules and the rearrangement of atoms into new molecules with consequent changes in the sum of all bond energies in the set of molecules that are matched by changes in kinetic energy. And in second column, weathering and the role of water in Earth's surface processes, an internal process, water content of magma. And these are the questions. How fast do different rocks weather and why does this matter? And how does the structure of minerals in rocks change? How fast or slow they weather and why? And a lot more. And let's proceed to incorporating earth science into physics. Same lang gihapon ang sa first column, second column, and third column. In first column, types of interactions, gravity. In Earth and Space Science, DCI, Earth and Solar System. And the question, why are certain planets visible only at certain times of the year? Here are some activities that we can use to integrate earth science into other science classes. First is the modeling the formation of ocean currents. This integrates chemistry and physics with earth science. The overview. In BICE's new Modeling the Formation of Ocean Currents lesson, students do experiments with models of ocean salt water, cold sea water, and warm water to help them understand how cold water and salty water are denser than warm and less salty water. This prepares them to understand the important process of the great conveyor belt of water and energy through Earth's interconnected global ocean. The lesson is designed for grade 5 to 12 students with a variety of enrich or extend activities listed at the end of the lesson to help you meet the needs of all the learners. For instance, it is applicable to high school chemistry and physics classes as well as the earth science classes. The teacher will prepare this illustration, and these are the guiding questions. First, how and why does ocean water move? Second, why is that process important for life on Earth? Third, how might the process be changing due to human activities? Fourth, how can we help restore balance to the thermohaline circulation patterns on Earth? And these are the objectives. First, students will measure salt accurately to create saline solutions to model seawater of different salinity levels. Second, students will experiment with different saline solutions and fresh water and demonstrate understanding that increasing salinity increases water density. Third, students will create models of warm and cold water, seawater, and slowly mix them together, then demonstrate understanding of how decreasing water temperature increases its density. Last, students will form hypotheses to predict the results of their experiments, record their observations, and compare the result with their predictions in writing. Next activity is albedo melting ice and feedback loops. This activity integrates physics with earth science. Overview. In BICE's new albedo melting ice and feedback loops lesson plan, students gain experience with the scientific method while they do 2 experiments to learn about how changing the reflectivity of Earth's surface materials and feedback loops impact Earth systems. Also, students gain experience with the scientific method while they do 2 experiments to learn about how changing the reflectivity of Earth's surface materials and feedback loops impact Earth systems. First, albedo differences in reflectivity of surfaces. Second, melting of ice on land and sea. Third is feedback loops. Here are the instructions. First, the class goes outside to observe the phenomenon of albedo firsthand. Second, then they design experiments to test the important role albedo plays in determining how much incoming solar radiation is absorbed by a substance. Last, they create diagrams to illustrate the process and the concept of feedback loops. And in part 2 of the lesson, students investigate 2 ways that the melting of ice impacts Earth systems. They test how floating ice in a container representing a sea ice and ice melting from outside the container representing ice on land affect the container's water level. And students discovered the melting land ice, the glaciers, raises sea level, but the melting of sea ice does not. And melting sea ice does, however, reduce albedo and thus lead to more absorption of solar radiation and more warming. They will also connect the results to the concept of positive feedback loop and how it can greatly magnify the impact of an initial change in a system, and in this case, how warming leads to melting ice, lowered albedo, and more warming. Enrich or extend activities are listed to help you meet the needs of all the learners. And guiding questions. First, how does the reflectivity or albedo of different substances affect the amount of energy they absorb? Second, how does melting of ice in the sea and on land affect Earth's systems? Third, how can feedback loops impact Earth's systems? Fourth, how can changes in albedo and the amount of ice impact Earth's climate and vice versa? The objectives of the activity. Students will plan an experiment to first test the effect of albedo on the temperature of different substances. Second, help them understand how the reflectivity of different types of planetary surfaces can have enormous impact on Earth systems. Third, students will create models of sea ice and glaciers into containers, testing how the melting of each affects water levels. Last, students will form hypotheses about the possible connections between albedo, melting ice, and sea level and communicate their ideas orally and in writing. Students will be able to explain the connections among albedo, melting ice, sea level, feedback loops, and climate change orally and in writing. Next activity is the Carbon Travels Then and Now. This activity integrates biology, chemistry, physics, and ecology with earth science. Overview. Carbon travels then and now. Lesson plan and simulation. Students play the role of carbon atoms to learn about the carbon cycle and how it is changing. Adapted from the Carbon Travels activity at STEM Earth Central, students can create 2 carbon cycle diagrams, visual models of the cycle before and after the Industrial Revolution. They reflect on the game and how scientists believe humans are impacting this critical Earth system. Numerous enrich or extend activities are listed to help you meet the needs of all the learners, including ideas for students, project, and detailed reading titled The Fast and Slow Carbon Cycles that is appropriate for high school chemistry classes and other more advanced students. The teacher will use this illustration, and here are the guiding questions. How is the carbon cycle changing due to human activities? How are changes in the carbon cycle altering Earth's climate and other systems? And how can we help restore balance to the carbon cycle? The objectives of this activity are first, students will participate in 2 simulations of the carbon cycle before and after the Industrial Revolution. Students will create 2 models of the carbon cycle representing how it has changed since the Industrial Revolution. Lastly, students will create written explanations of their models to demonstrate their learning. Students will explain how human activities have been changing the carbon cycle orally and in writing. Those activities or the lessons are aligned to the Next Generation Science Standards or the NGSS and Common Core State Standards. And here are the sources of this topic. Thank you so much, and God bless.